Okay, students, we're going to take a look at similar figures today. If you will take out your note sheet and let's fill this out together. At the top, similar figures have the same shape but different size, or I want to say, but not necessarily the same size. And then figures are similar if two things have to happen. The first thing is corresponding angles have to be congruent. So corresponding angles are congruent. They are equal. And the second condition, corresponding sides are proportional. So corresponding sides are proportional. The ratio of corresponding sides is called the scale factor, which we talked about yesterday. F-A-C-T, and that's O-R. Okay, so look at this example. We have two triangles here. We have triangle ABC and triangle DEF. Are these triangles similar? Well, corresponding angles, we have to look at the first condition, if they're congruent. And if you notice these arcs for triangle A or angle A and angle D, they have the one arc through, and that means that they are congruent. So here I'm going to write angle A is congruent. That's the congruent symbol, to an equal sign with a squiggly over it. Angle A is congruent to angle D. And again, from those one arcs, we know that they are congruent. Now let's look at angle B, and you can see it has the two arcs through it, just like angle E. So we know that angle B is congruent to angle E. And then finally, look at the angle C. It has three arcs through it, and so does angle F. So those are congruent. So I have angle C is congruent to angle F. These angles are corresponding and these angles are congruent. So that takes care of the first condition, that corresponding angles are congruent. For example, if angle B and angle E were different measures, then these two triangles would not be similar. The next thing we need to look at is we need to decide if corresponding sides are proportional. Well, if you take a look, side AB, and I'm going to put a tick mark through AB, it corresponds, well, it's not the same. I'm not going to put that tick mark. But AB corresponds to DE. Okay, we have 4 to 8. And then if they are proportional, then BC, which corresponds to EF, and I'm looking at the side that's the second longest in both triangles. So BC corresponds to EF, and then that would have to be equal to, and if you look at the longest side, AC and DF. So if these corresponding sides are proportional, if they are equal, then the two triangles are similar. And if you look at this, let's go ahead and plug the numbers in. If we take 4 over 8, that has to be equal to 5 over 10, which has to be equal to 7 over 14. If we simplify these ratios, then we get 1/2 for those. And then question 4 says, what's the scale factor of triangle ABC to DEF? Well, to get from 4 to 8, you multiply times 2. 5 times 2 is 10. 7 times 2 is 14. So my scale factor is 2. And then it says, what's the scale factor of DEF to ABC? And if you look, what's happening? 8 divided by 4, 10 divided by 5, 14 divided by 7. Triangle ABC is half the size. Each side is half the size, so there's our scale factor there. Take a look at similarity statement. The symbol for similar is just the little squiggly. It's like the squiggly we use with congruent sign, but no congruent sign. It says a valid similarity statement must match corresponding angles and sides. So a similarity statement for these two triangles would be triangle ABC is similar to triangle DEF. They are not congruent, but they are similar, meaning they have the same shape but not necessarily the same size. Their corresponding angles are congruent and corresponding sides are proportional. The next part, finding measure. Because the sides of similar figures are proportional, you can use a proportion to find the missing side length. We just match up the pair of corresponding sides. So, and if you take a look, first of all, are the angles congruent? Here we have one arc. Those are congruent. And then our double arcs there. So corresponding angles are congruent. So now let's see. We don't have letters for these sides, but we have side 2 corresponds to side 3 in the larger. That has to be equal to 8 corresponds to x. So 2 to 3, 8 to x. Notice I have to start with the same figure each time, 2 over 3, which equals 8 over x. We cross multiply, we get 2x equals 24. Divide by 2, x equals 12. Okay, let's take a look. We'll look at one or two more problems. Let's take a look at number 7. Now, it might be helpful for me. I would like to redraw this other triangle, and I'm going to do, and in the same position that this is. And I'm just going to label those sides. So, my longest side would be right here, 12.75. This is a right angle, okay. And my side next to the longer side next to the right angle, it's my second longest side, is going to be right here, 11.25, and then the shortest side here. So that's when I go to redraw these, I look at the longest side, the shortest side, the angles I have, like the right angle. So now I can see these better like this, and it's easier for me to match up corresponding sides. So first, we need to determine, are the angles congruent, corresponding angles congruent? And yes, they are. Let's see. Right here, we had just one arc here, and then your double arc there. So 8 corresponds to 6, the two shorter sides. Now, I have to, since I'm looking for x, I have to include this side. It's not going to help me to use 17 and 12.75. So 8 corresponds to 6, and then we want our x corresponds to 11.25. And then, so there's our proportion to solve. We cross multiply, get 6x equals, and then on my calculator, 8 times 11.25, and that gives me 90. Divide both sides by 6, x equals 15. This side right here equals 15. Okay. I want you to do number 9, and I want you to do number 9 now. Now be careful here, because these two triangles, if you can see, like this is 3 arcs here, this is 3 arcs here, they are flipped. I'm going to take this small one and I'm going to draw it in the same position as the other one, and I'm going to label it. So you do that, pause this video, work the problem, and then come back and see if you got it correct. Okay, let's see if you got it correct. Now, if you will notice, I've flipped this so it would be in the same position as this. So this angle right here comes over here. That's the 1. and then I have the one with 2 arcs here. Whoops. 2 arcs here, and then our 3 arcs here. So I put the triangles in the same position. Across from the one with 2 arcs, here's our 24, and then here's our 21. So I flip that and I put it in the same position. So now we have X, which corresponds to 24, equals, and then we have 28. That corresponds to, now when you look at the 28, notice it's between the angle with 1 arc and 2 arcs. So it's going to correspond to the one that's 21. So that should be your proportion. Then we're going to cross multiply. I get 21x. 24 times 28 gives us 672. Divide both sides by 21. And we get x equals 32. I hope that you got that problem right. Go ahead and work the other problems. Be careful when you get to like number 11 and number 12. Just a hint on number 11, you've got this small triangle and you've got the large triangle. So those are the 2 triangles you're going to use. This small one here, let me highlight that for you. And the large one, which would be the whole thing. And then be careful as well when you get to number 12 to be sure that you are getting the right size that correspond with the right ones. And if you notice on number 12, if I have C, D, E, then I should have F, G, H when I redraw that. So they would be in the same position, F, G, H. Between F and G, here is my 13 1/3. Between F and H, here's my 10. And then between G and H, 11 2/3. And that's for that triangle there. Okay, good luck. Finish the rest of the problems.